Video, we're going to be talking about Chapter 6, Ionic and Molecular Compounds and their formations. And the topics we're going to be covering here in this chapter. This is a fairly large chapter, so there's a lot of content to cover in this chapter. And this is, in a way, one of the most important chapters because this is kind of the foundational chemistry on which the other chapters will build on. Oops, sorry, I didn't mean to do that. So the topics we'll be covering in this chapter are 6.1, how ions are formed, and then 6.2, writing formulas for the ionic compounds, and then 6.3, how to name and write the formulas for the ionic compounds, and then polyatomic ions, look at what they are, and then molecular compounds, how they're formed, which is by sharing of electrons as opposed to transfer of electrons in ionic compounds. And then Lewis structures for molecules and the polyatomic ions. We had looked at Lewis structures, the dot symbols for elements, but now we're going to look at how those structures for molecules and polyatomic ions can be formulated or can be drawn. And then we will define what electronegativity and bond polarity are. And then based on bond polarity, we'll look at what the shapes of molecules are. And then the last topic is learning about the attractive forces in compounds. So in this particular video, we'll deal with just the first section, and that's 6.1 about the formation of ions. So here you see a pharmacy technician working with the pharmacist, filling out a prescription. And so when they get a prescription, they it's important to know what that medication is, what its chemical composition is, so that they they can make sure that they measure the dosage out correctly, and then make sure that the patient is given the proper instruction on how to take that medicine. So some of the skills that would be carrying over is, again, using positive, negative numbers, using equations, and then knowing the electron configuration and Lewis symbols. So here, 6.1, section 6.1 deals with how ions are formed, and ions are formed by transfer of electrons. Okay, so when a positive ion, which is usually a metal ion, those are formed by losing of electrons. Remember, metals can give up electrons very easily. They have low ionization energy, the energy required to make an ion, whereas non-metals, it's easier for them to gain electrons. They have very high ionization energy, but they can form ions by gaining electrons. All right. Now, the bond that holds the positive and the negative ion together are just attractive forces. So it's not like a physical bond. However, it is a very, very strong bond. All right. So the goal here is to know how to write the symbols for very simple ions of the representative elements, the group A elements. Okay. So you have a picture here showing you an ionic compound like NaCl, and as you can see, what's holding the Na plus and the Cl minus is that strong attraction between opposite charges, all right? And that's called the ionic bond. Molecular compounds, on the other hand, are, so this is ionic bonds are formed between a metal and non-metal. whereas molecular compounds or molecules, or the covalent bonds, are formed between two or more non-metals. All right. Now, in this case, there is a physical bond, and electrons are being shared between the oxygen and the hydrogens in water. And here in propane, again, there's carbon and hydrogens, and this is also formed by sharing of electrons. Okay. So chemical bonds, ionic bonds, are formed when an atom will lose or gain electrons, and if it is a covalent bond, by sharing of valence electrons. So only the valence electrons are involved in bonding, and valence electrons are the electrons in the outermost orbital, um, or the outermost valence shell, all right, the outermost energy level. The goal here is either to lose or gain valence electrons in order to obtain an octet. That an octet means 8 valence electrons. So this is called as the octet rule. All right. So ionic bonds will occur when the valence electrons of metal are getting transferred to the non-metal, whereas in covalent bonds, two or more non-metals start sharing electrons and attain the octet. So the octet rule holds true whether it's an ionic bond or a covalent bond. So here you see a picture of a metal and a non-metal, all right? So the metal is losing an electron because it's easy for it to give up that electron, and the non-metal grabs it, and then if you count up the electron dots, you see 2, 4, 6, and it's one short of an octet. So it grabs that, and now it's got its octet. Remember, an electron has a negative charge, so every time an electron is taken, it brings with it its negative charge. So now the neutral nonmetal is negative because of the extra electron. Because of the fact that the metal has lost an electron, when it was neutral, the number of positives matched the number of negatives. But however, now that it lost an electron, it's left with a charge imbalance, so that makes it positive. So now the positive and the negative charges are attracted and the ionic bond is formed. Now, on the other hand, when you have two non-metals, you can see that this non-metal is one electron short of an octet, and so is this. So what if they shared their single electrons? In this way, both of them now are able to equally share two electrons between them, and so both are able to get octets. Okay, so that's a covalent bond. So in ionic bond, the ions are formed from metals by loss of electrons, and the number of electrons lost is equal to the group number. So all the metals in group 1A will lose one electron, in 2A 2 electrons, and then in 3A 3 electrons. All right. Metals have low ionization energy, so that energy needed to pull out an electron from a neutral atom, and so the metals easily lose one or more of their valence electrons, end up with a positive charge. All right. So metals forming positive ions, the positive ions are referred to as cation ions. Okay, so metals form cation ions or positive ions. So they lose electrons until they have the same number of valence electron as the noble gas that precedes them. All right, so they're usually going to aim for the octet. So if by loss of electrons, they'll end up having an octet, right? So you see here with sodium. Now sodium has 11 protons, 11 electrons in its neutral atom, all right? But if you look here, that lone electron, the 11th electron, is in the third energy level, all right? It's 3s1. However, if you look at 2s2, 2p6, you have an octet in the inner energy level, the second energy level. So sodium prefers to give up this electron and then achieve an octet by giving up the electron. So now it has 10 electrons but 11 protons, and that's why the sodium now has a positive charge, and the name of this ion is sodium ion. So it retains its name just like the atom. However, the suffix ion follows it. Now, this is magnesium. So magnesium has got 12 electrons, 12 protons. Again, if it loses those 2 electrons in the third level, then it's going to get an inner octet, and that's what it does. All right. So if you look at cations, they get smaller because they've lost one entire energy level. All right. Same thing with magnesium, it's getting smaller, and now it forms the Mg2 plus, the magnesium ion. So nonmetals, we're only looking at those nonmetals in 5A, 6A, and 7A. And these are the nonmetals that form negative ions. These negative ions are also referred to as anions. Now for these nonmetals, rather than give up 5 electrons from their valence shell, it's easier for them to gain electrons, one or more electrons, to get the octet. All right, so they obtain their octet by gaining electrons, and how many electrons they gain is dependent again on this group number. 8 minus 5, that means it's 3 short of an octet, so it grabs 3 electrons. And so all the group 5 nonmetal ions will have 3 negative charge. Group 6, 6 minus 8, so they will have 2 negative charge. And then group 7, 7 minus 8, so they'll have 1 negative charge in their nonmetal ion. So chlorine is a typical nonmetal. It has 17 electrons, 17 protons, all right? So it's 1 short of an outer octet, all right? It just needs 1 more electron. So if it grabs 1 electron from the sodium, the electron that is given up by the sodium, then it can form an octet in its outermost energy level, all right? And that's the Cl minus ion, the chloride ion. So the sodium, so here you see that the nonmetal ion gets bigger, all right, more diffuse. The more electrons you add, the more spread out becomes the atom size, all right. So the metal ions get smaller, but the anions or the nonmetal ions get bigger. Now, once the chloride ion forms, it can, because of strong attraction between opposite charges, the Na plus and the Cl minus come together to form sodium chloride. So if you look at table 6.1, it gives you a listing of all the metal ions for the various groups. Now, the charge on the metal ion is the same numeric value as the group number. So all group 1, because they lose 1 electron, they're all got a +1 charge. The name of the cation or the metal ion is the same as that of the element. Group 2 will lose the 2 electrons, so again the charge will be the numeric value of the group number. So it's Mg2 plus, Ca2 plus, Ba2 plus, and then group 3, which is aluminum, forms a 3 plus. Now in non-metals, they form negative ions, and the charge on the negative ion is group number -8. So 5 minus 8. So nitrogen and phosphorus have a 3 negative charge, and the name ends in the suffix "ide." So instead of nitrogen, it's nitride, phosphide. 6 minus 8, so oxide and sulfide are 2 negative, and 7 minus 8, fluoride, chloride, bromide are 1 negative, and we'll stop here.